Okay, lovely. So welcome back, Matrix. It's really nice to have you with us again this evening on Thursday. As you guys well know, this class from 6 until 7 deals with the same sort of contexts that we were dealing with earlier in the week, except that it's going to be a little bit more difficult. All right, so now that we've been speaking about working in one triangle, we need to see how we can cope with working in two or more triangles. So things are going to start to get a little bit more complicated. Right? What they tell us in this diagram here on the right-hand side is that we have triangle ABC, right? Well, I've just got a few triangles there, but anyway, and we can see that line ED is parallel to line BC. Okay, so now what I'm going to do, now remember I said to you the last time, your highlighter is your best friend in geometry, okay? So do not be afraid to highlight stuff. Okay, so line ED is parallel to line BC. So that means that the sides that have been cut into proportions is going to be this one over here, AE and EB, would be equal to AD over DC. The other thing that we notice is that we've got another pair of parallel lines. In this case, EC is parallel to FD. So now here, again, we've got sides that have been cut into proportions. So this side, AF over FE, and here, DE over DC. What's so important with questions like this is to first identify which triangles you can work in. In other words, identify which triangles you can apply the proportionality intercept theorem to. Remember, there has to be one line parallel to the third side of the triangle that cuts the remaining two sides into the same proportions. That's what you are looking for, okay? Additionally, I think it's very helpful for you to highlight the parallel lines and then draw your triangles. So you can see here I highlighted the two lines in green, and then I highlighted the green triangle, and then I highlighted the two sides that were parallel in the blue triangle, and then I draw the blue triangle. So now it kind of pops out to me. I can see which two triangles I can work in. I can work in ABC, the green triangle, and I can also apply proportionality intercept theorem in triangle AEC as well. Okay, now let's go and have a look at the information that they've given us. They've told us that AD over DC is 5 over 4. Okay, so that's 5 over 4. They've told us that AF, let's do this in a different color. So AF over here is 3x minus 5 units long. And FE is 2x units long. The question asks us to calculate the length of EB, and even though it doesn't say so, it implies that we need to do this with reasons. Okay, so we absolutely need to provide reasons every step of the way. All right, so now EB is this side over here. There's EB. So a good way to approach these problems is to kind of start with what it is that you want to find and say to yourself, well, what would this be equal to? All right. Can you see, Matrix? EB is the piece between E and B on the left-hand side. On the right-hand side, the piece of line segment that it's in proportion to would be DC. All right. So in other words, if we said EB over AE, for example, that would be exactly the same as
DC over AD.
Just say that again.
DC over AD.
DC over AD. All right, perfect. But now there's a problem, all right, because we don't know how long these sides are that have got the X's in them. So even though the question doesn't tell us to, it's implying that we first need to work out the values of X. Right, so we can't go and work AE over EB or AB over EB is AC over DC because we've got these X's on the left-hand side. So now that's why our attention has been focused to the blue triangle. 2x over 3x minus 5 would be equal to what over what, Matrix? 2x over 3x minus 5 is equal to what over what?
4 over 5.
Lovely, Nobuhle. Is equal to 4 over 5. Don't forget proportionality, intercept theorem, name the parallel lines. Okay, so FD parallel to EC. So this is what we were doing in our previous lesson. We need to cross multiply. This gives us 10x is equal to 12x minus 20. So that gives us minus 2x equals negative 20, which means that x would be equal to 10. There's just one answer for x in this case. All right, so if x is equal to 10, then it means that side FE is now going to be equal to 20 units. And side AF is going to be equal to 3 times 10, take away 5, means it's going to be equal to 25 units. So AF is now 25 units. And we can see that FE is equal to 20 units. Does that make sense, Matrix?
No, ma'am, we just
Oh, ma'am, can you please explain?
Okay, where did I lose you? Did I lose you up at the top here when I did this?
The units.
Oh, with the units.
Yes, ma'am.
Okay, so what I was doing is I'm substituting. Okay, so if I know that x is equal to 10 and they've told me that FE is 2x, then FE means 2 times 10, which is 20.
Oh, okay, thank you.
I'm just substituting into what they gave me. And then over here for AF, they told me AF was 3x minus 5. So again, I'm just subbing x in. So 3 times 10 is 30 minus 5 is 25.
Oh,
Does that make sense now?
I get it now. Yes, ma'am.
Okay, all right. Okay, no problem at all. All right. So now that means that we know the length of AE. We can work out the length of EB because we know what proportions the other side, now we're looking at the green triangle, what the other side is, which is AD over DC. So now that we've finished working in the blue triangle and we've solved for X, now we need to go back into the green triangle and make a proportion with EB in it that's going to help us solve our problem. All right, so I am going to say EB over AE. And what will that be equal to?
DC over AD.
That's it.
Yeah.
That's it. DC over AD. Good. Well done. Remember proportionality intercept theorem. I'm working in triangle ABC, where side ED is parallel to side BC. Now I can go ahead and substitute. EB is what I want, so I'm going to leave that as EB. AE I now know is 20 plus 25. Does that make sense to everybody? AE?
Yes, ma'am.
Okay, so AE is the sum of these two, so it's 25 plus 20, which is 45. So this is going to be over 45 equals DC is 4 is 2. AD is 5. Okay, and now I want to cross multiply. So I'm going to multiply the 5 with the EB. That's going to give me 5 EB. And I'm going to cross multiply 45 with 4. That's going to give me 180. And then I need to divide both sides by 5. So 180, that's it. Divided by 5 means that EB is going to be equal to?
36.
Good. Well done, Tubile. I quite agree. 36 units. Okay, how does that feel, Matrix? Does that make sense?
Yes, ma'am.
Okay. All right. Are you ready to try one on your own now? No, Tabile, you're not going to lose marks if you don't write units. That's fine. Tatsu, what did you want to say? Sorry.
Can you please explain again? Because I was doing the quiz, so I wasn't
Oh,
here.
so you missed all of that. Okay,
Yes.
that's fine. I tell you what. I was just thinking if we can find one that other people perhaps want to carry on with in the meantime, and then we can explain again. Who else would like me to explain again? If you can just pop something into the chat, or just so I can see where people are at. Okay, thank you, Mrs. Maduna. Okay, so it seems as though a lot of you are saying that you want me to explain it again. Okay, so which I'm obviously more than happy to do. All right, so let's do that. Let's go back up here. Okay. So it does start to get a little bit more complicated. What I'm going to do is just get rid of all of this color so that we can start this problem afresh. So just rub all of this out, and then we can start again. Now, what makes this particular problem more difficult than the previous one is that we've got more than one pair of parallel lines. Can you see that? Whereas before we just had one triangle with one pair of parallel lines, now we've got two pairs of parallel lines. Okay, so the best thing that you guys can do for yourselves to help you answer questions like this is you need to identify which triangles you can work in, because you cannot just apply proportionality intercept theorem to any old triangle. Okay, so if I say, so for example, here's a triangle, AED is a triangle, but why can I not apply proportionality intercept theorem to this triangle? Why won't it work? Can anyone tell me?
There's only one parallel line.
Absolutely, and it's not even parallel to one of the sides. Hey, Tabile. So
Yes,
I
ma'am.
can't, exactly. So that means that I cannot apply proportionality intercept theorem to triangle AED. Remember, if I want to apply proportionality intercept theorem, I have to have a side parallel to one side of the triangle that cuts the other two sides into the same proportions. Okay, so what I recommend you do is this, right? Take your highlighter and highlight the parallel lines. So there we've got ED and we've got BC. Now draw the triangle that they lie in, okay? So in other words, it cuts sides AB. So because ED is parallel to BC, it cuts AB and AC into the same proportions. So now you've highlighted that for yourself. But we have another pair of parallel lines here because they've told us EC is parallel to FD. So that's those blue ones over there. So now we change color. We go and get yellow, all right? EC parallel to FD. So let's highlight those lines as well. There's FD and there is EC. Now draw those triangles as well. So that means that FD parallel to EC cuts AE, badly drawn by me, AE, and AC into the same proportions. So can you see here, matrix, we've got two triangles. All right, all we can see is lines all over the place. Where do we start? But it's really not that bad once we've highlighted them and we can see which triangles we're allowed to work in. So we can apply proportionality intercept theorem to triangle ABC because ED is parallel to BC. And we can apply proportionality intercept theorem to triangle AEC because FD is parallel to EC. Okay. Now let's fill in some of the information that's been given to us. They've told us AD over DC is 5:4. So that's a ratio, 5:4. They are not telling us that AD is 5 units long and that DC is 4 units long. That's a ratio, okay? So the other way that we could have written that is like this. AD is to DC equals 5:4. Okay, remember fractions and ratios are the same. Then the other bit of information that they've given us is the length of AF. Okay, so that's this bit over here in pink. They've told us it is 3x minus 5 units long. And they have also told us that FE is 2x units long. The bit that they want us to calculate, the thing that they're asking us to find, is the length of EB. So now you say to yourself, in which triangle does EB lie? EB is part of the yellow triangle or EB is part of the blue triangle? Which one is it part of? Exactly, Tatso. Okay, so EB is part of the blue triangle, all right? So when we want to work out EB, we've got to be working in the blue triangle because ED is parallel to BC. But what is the problem with that? We can't start there because we do not have enough information about the blue triangle. Sure, we've got AD over DC, but on this side over here where we've got AE over EB is our unknown that they're asking us to find, our AE is also unknown. Okay, so in other words, we now need to turn our attention to the yellow triangle to help us work out the length of AE. We need AE to get EB. Okay, so it's like you looking in your cupboard, you decide one day that you're going to make muffins and you need certain ingredients, all right? So you go and you look in your cupboard and you can see you've got sugar, but you don't have flour. So you write on a list, when I go to the shop, I need to buy flour and I need to buy chocolate chip. But at home, I've already got baking powder and a muffin pan or whatever the case is. It's looking at what you're trying to do, what's missing. How can I go and get what's missing in order to figure out what it is that I want? Okay, so here to get EB, we need AE. AE is missing, so that means we now need to look in the yellow triangle and work out what AE is equal to. So now, working in the yellow triangle, the only proportion that we can possibly make is this one. So AD over DC is going to be equal to AF over FE. Okay, so we're working in the yellow triangle. Proportionality intercept theorem. And that is because FD is parallel to EC. Now I'm going to go and substitute in. So AD is 5. DC is 4. AF is 3x minus 5. FE is 2x. Okay, so now I've got a binomial, so that means I need to cross multiply. All right, and I need to cross multiply 2x with 5 as well. So 2x times 5 is 10x. 4 times 3x minus 5, let's just get that down. So 10x is going to be equal to 12x minus 20. Okay, Matrix, you've all gone very, very quiet now. Are you okay? Is this making sense?
Yes, ma'am.
You sure? Okay.
Yes, ma'am.
All right. So we've got 10x minus 12x on the left is equal to minus 20 on the right. So this gives us minus 2x on the left equals minus 20 on the right. And we're going to divide both sides by negative 2, which means that x will be equal to 10. Okay, so now that we've solved for x, we can work out the length of AE. So if x is 10, that means that AF is going to be 3 times 10 minus 5, which gives us 25. And FE is going to be 2 times 10, which gives us 20. So that means that AE is 45 units. And now that I have AE, I can go back into the blue triangle and I can work out the length of EB. Okay, so numerous ways in which I can do that, or different proportions that I could write. I'm just going to do this. I'm going to put the unknown that I'm looking for into the numerator. So I'm going to put EB at the top and I'm going to put AE at the bottom. And that means on the other side in the blue triangle, I've got to put DC at the top and AD at the bottom. Because I'm doing proportionality intercept theorem, I have to state that this is what I'm doing. I have to name the parallel lines. So in this case, it's because ED is parallel to BC. Okay, I'm just going to move this up a little bit. And now we want to go and substitute in. All right, so EB over AE was 45. Then if you remember, we only had the proportions of DC and AD. It was 5 is to 4. So that's going to be 5 over 4. And now again, Matrix.
The other way around, Lee. 4 over 5. So DC is 4.
Oh, yes, of course. Sorry. Thank you so much. That wouldn't have helped, would it? Okay, thank you. So yes, because I put EB at the top, so that's got to be 4 over 5. Quite right. So EB over AE is DC over AD. All right, and now we're going to cross multiply. Okay, so that gives us 5 EB is equal to 180, divide both sides by 5, and EB will be 36 units. Good. Okay, so now there's a question. It's a pleasure. Okay, Lindell, what you says, ma'am, since 4 and 5 aren't the lengths of those sides, is it possible that we get the same question but asking us to calculate the length? Absolutely. Absolutely, Lindell. But I think in this situation over here, they would need to give you just a little bit more information. They would need to tell you either what AD is equal to, or what DC is equal to, or what AC is equal to, and then you would be able to work out the length of that side. Okay, so for all you know for now is that it's in the ratio 5 is to 4. Okay, but yes, they could certainly ask you to do that. Does that make a little bit more sense, guys?
Yes, ma'am.
Okay, all right, so we have to work in more than one triangle. Now, let's find, okay, we're going to try this one. This is our traffic light. You guys are going to try this one, okay? So I actually want you to do this one rather than the other one. Let's move that out of the way. So now you guys are going to have an opportunity to work on this particular question. All right, so let me just make it a whole bunch bigger. There we go. Let's get rid of that. Okay. So, very important. Read the information first. In triangle QRS, T and U are points on RS, and W is a point on QS, such that, now again, look here, matrix, two pairs of parallel lines, QT parallel to WU. So again, start off, highlight your parallel lines, and then draw your triangle. So now you can see which triangles you can work in. Okay, and then QR parallel to WT. So QR is this one down here. Parallel to WT means we can also work in this triangle. Okay, you see how nicely that pops out to you now. You can see the triangles that you can apply proportionality intercept theorem in. More information that's been given to us. QW is 12. Okay, so QW is 12 millimeters. Okay, so they're giving us lengths. WS is 11 millimeters. Let's pop that on. TU, that's this little bit over here, and it's equal to 6 millimeters. They want you to calculate the length of RS, so that's this whole blue side over here, RS, correct to the nearest whole number, right? So I'm going to let you guys give this one a try. We're going to give you 5 minutes and let's see where we end up. Okay, and of course, if you need any assistance, Coco and I are right here. Okay, how's it going, Matrix?
Good, ma'am.
Is it good?
Yes, ma'am.
Cool, Nabuhle. Are you done? Are you ready to talk about it, or do you want a few more minutes?
I'm not sure about the others, ma'am, but I am done.
Okay, all right. Thank you, Nabuhle. Okay, Tatso also says she's done. Okay, Zianda, but they did say correct to the nearest whole number here, so don't feel too bad. Ongeziwe also says he's done. Okuhle is done. Cool. Done. Done. Okay. Okay, Kosiami, it's all right. All right, well, since so many of you seem to be finished with this particular one, let's see what you got. So put your answers into the chat. Okay, Michaela. Coco, what do you think of all these metrics saying the answer is 24?
I think they're right. I think that's the answer I got. So
Indeed. Tatsu's got 25.
I can see where that might come about, but that means Tatsu was maybe rounding off everywhere within the question.
Yes, instead of at
just
the end.
Which is very
Absolutely.
important.
Yeah. Okay, so Tatsu only round off at the very end, okay? Not all the way through the question. All right, well, the fact that so many of you have got the same answer, well, that is the correct answer, I think means that you were able to do that question and you understand it, and that's great. So if that is all right, you don't need me to work through it with you? I don't think so. If you do, you would say so. No. Okay, Tatsu. Perfect. All right. Well done. Okay, that's really, really good. Do you see how much the highlighting helps? Okay, it really, really makes a difference. So I strongly, strongly, strongly encourage you to do that. Okay, because I think it makes all the difference in the world. All right. So now we're going to do this question. So I'm just going to grab it and bring it down here. And again, I want to challenge you, Matrix, to rather try and do this on your own rather than me doing the problem for you. If you get stuck, then of course we're here to help you. All right. But I want you to try and do it on your own first and just see how it goes. Again, I'm going to highlight some information. It's a little bit different to what we've done before, but I mean, we're always going to expect to see something that's a little bit different. So in triangle ACF, we've got AF, so that's this side over here, which is, hang on, let's just do a highlighter rather. That's this side over here. All right, parallel to BG. Okay, and that means there's triangle ACF, fine. They have told us that ED, oh, hang on, let's just work with the other triangle. And then in triangle CEF, let's just highlight that first rather. We've got DG parallel to EF. So that's this triangle over here. Okay, they have then given us some information. They've told us that ED is 22 centimeters. They have told us that DC is 33 centimeters. They've told us that BC is 15 centimeters, and they've told us that AB is X. All right, the question now asks, calculate the length of X. Right, so there's your two triangles. We're working in more than one triangle. How are we going to calculate the length of X? Anyway, you give it a try and then we'll talk about it in 5 minutes.
And when you're done, guys, you can just pop done in the chat so we know how many of you guys are done with the question.
Yeah, good idea, Coco. Wow, Tubile is done. Amahle Shozi, we're going to talk about now how we're going to calculate X. I will go through this one with you because it's a little bit different to the previous one. And it's important that we say everything that we need to say if we want to get all the marks. Okay, Michaela's done, Keelan's done. Okay, so Ziyanda's done, Letabo's done. Now, with this question, if we didn't understand what we were doing, we would be very, very tempted to just do this, all right? So if I write this matrix, X over 15 equals 22 over 33, am I going to get all the marks?
No.
No, ma'am.
No, I'm not. No, I'm not. It's not okay that I make that statement. The reason that I can't do this, why can I not do this? What's wrong with what I've said?
Because they're not the same parallel lines.
Absolutely. It's not even a, Michaela, it's not even a triangle. Okay, so in other words, I'm making a statement about an object that is actually a quadrilateral. Look there, it's got 4 sides.
Oh.
Okay, So I can't apply proportionality intercept theorem to quadrilaterals. It only applies to triangles, right? Eventually, this is what I'm going to end up with, but I have to get there in the correct way as well. Okay, so that means I need to do this, right? First of all, I'm going to say x over 15 is equal to FG over GC.
GC.
Okay, exactly. And my reason here?
Proportionality
theorem. Good, Tabile. And that's because AF is parallel to GB. Then I'm going to go into the yellow triangle, and I'm going to say that 22 over 33 is also equal to FG over GC. Proportionality, intercept theorem. And now I'm working in the yellow triangle. So FE parallel to
GD.
DG. Okay, so if two things are equal to the same thing, then they must be equal to one another. Okay, so only now can I conclude that x over 15 is 22 over 33, but that cannot be my first statement. All right, and now I'm going to cross multiply, and then I can solve for x. So I've got 33x is equal to 15 times 22 is going to leave me with 330, if I've done that correctly, which means that x is going to be equal to 10. Did you guys also get x is 10?
Yes, ma'am.
Good. All right, so here what they could do is give us a statement reason mark. So there's the statement, there's the reason. So statement reason mark here, statement reason mark here, and then a mark on our answer. Okay, did that go well?
Yes.
Okay, all right. So are we ready to move on to something else? Can we have a look at something else a little bit more difficult now?
Yes,
Okay, cool beans. All right, so let's move that out the way and let's have a look at this problem. Okay, so in this question, in the figure, EHG is parallel to FC. All right, so let's go and highlight our parallel lines. EHG, that's this side over here, is parallel to FC. Okay, so again, draw your triangle. Okay, rather badly, but there we go. All right, they've also told us that AH is 6 is to HC is 5. And they've told us, let's change our color, that AE is 3 is to EB. So that's this whole bit over there is 7. Okay. Now, they've asked us to calculate the length of BG over CG. Okay, so no lengths are given. They've only given us ratios in this particular case. They haven't told us the lengths of any of the sides. Now, we've identified one triangle that we can work in. And if we have a look at what they're asking us for, all right, they're asking us to solve BG over CG, okay? So BG matrix is this whole line over here. CG is that one over there. All right, so they're asking us to end up working in the green triangle, all right? But that can't be the starting place because BG over CG would be equal to BE over FE, and we don't know anything about FE. We know BE, but FE is missing. Can everybody see that? Right, so that means we need to identify another triangle to help us solve EF. What triangle can we work in now, Matrix, to help us solve EF? Can anybody tell me?
ABC.
AFC.
AFC. Nabuhle, AFC. Why can't we work in ABC? Because we don't have one side parallel to the third side. Remember, we've got to have a line parallel to the third side of the triangle. Okay, so if this is EF over here, and that's the bottom side of the triangle, there is the line that will be parallel. So drawing our sides now, there's our pink triangle. That is our second triangle. Does that make sense, everyone?
Yes, ma'am.
Okay, all right. So, Tatso, we now have to start off working in the pink triangle. Remember, we've identified that it is EF that is missing. All right, so
Yes,
I am
ma'am.
going to say EF over
3.
3. And you're going to finish it off for me, Tatso. EF over 3 equals?
5 over 6.
Oh, you are so clever. Well done. So proportionality intercept theorem. And the parallel lines, Tatso, are?
Parallel lines are EH,
And?
FC.
Oh, there we go. Beautiful. Well done. All right, so we're going to cross multiply. That gives us 6. EF is equal to 5 times 3 is 15. Don't be scared. We can have fractions for lines. Okay, so this means that line EF is going to be 15 over 6 units long. Both of those are multiples of 3. So if we divide that by 3, we would get 5. And if we divide that by 3, we would get 2. So that's essentially 2.5 units. Isn't it? All right, but we could work with the 5 over 2. So actually, we don't know that we don't actually know that it's that long. All we know is that that's the ratio. So let's rather leave it like that rather than saying that it's 2.5 units, because we actually don't know the lengths. Okay, so now that we have EF, and we know that EF is 5 over 2. Now we can go back to the green triangle. Okay, remember they wanted BG, the whole side, over CG. So now working in the green triangle, if I say BG over CG, what is BG over CG going to be equal to, Matrix?
Over GE.
So BG over CG, we're working in the green triangle. So BG over CG is going to be equal to?
GH over GH.
EG over EH.
Yes.
EG over EH.
BE over BF.
PE over FE.
EF over PE.
Okay, now remember here, Matrix, you're almost there, okay? You guys are doing this really, really well, okay? I'm just going to get rid of the yellow. Right, so BG is this whole side, Matrix. Be careful, be careful, be careful. Right, let's use a different color. I'll use a darker green. So BG is this whole side. So the whole side over the bottom portion. Okay, the whole side over the bottom portion. So that's going to be equal to the whole side on the other side. Now here are parallel lines. So in other words, FC parallel to EH cuts BG and BE into the same proportions. Okay, so that means that BG over CG is going to be equal to?
EG over HG.
BE over FE.
Over FE.
Huh?
Does that make sense?
Yes, ma'am.
Okay. Tatsuo says it makes sense. What about the rest of you?
Ma'am, I don't understand.
I don't understand either.
Okay, so what you are doing is you're almost working upside down. Okay, so this triangle is drawn lying kind of on its side. Okay, just to highlight it again for you over here, right? It's the green triangle. Can you see the two sides that are parallel to one another?
Right.
The two sides that
Yes,
are parallel, let's draw them again. Let's just get rid of the green lines. Okay, so in this green triangle over here, here are your parallel lines. There and there. Okay, so because EG is parallel to FB, here is the triangle. So the triangle is EBG.
Oh.
Okay, so
Ma'am, I think you should draw the triangle.
almost kind of look at it like it's almost upside down. Does that make sense to you? Almost like it upside down in this particular case. All right.
Ma'am, I
So
think you should draw the triangle again.
you could draw the triangle again. All right. So what you've got in this situation over here is triangle. So this line over here is EG. Right, then EB is a very short, oh, hang on a second, that's popped up. Okay, so EB is a very short line, and line BG is a much, much longer line. Okay, and then we've got another line that's parallel over there, that would be F, and there's C. Okay, so this side over here is parallel to that one over there. So I've drawn the green triangle over again. So this line over here, EG, is this one. Here's EG. Okay, line FC is this line over here. All right, and there's B at the top. It just happens to be down in the corner over here, but there is your triangle. Okay, so now they've asked us for BG over CG. So that's BG over CG. So BG is the whole side over CG is the bottom portion. So that's why it has to be equal to BE over FE on the other side. Does that make sense now?
Yes, ma'am.
You sure?
Yes, ma'am.
Okay. So again, proportionality intercept theorem. We're working in the green triangle where EG is parallel to FC. Oh, good to be there. I'm glad. Okay, and now we can go and put in the things that we calculated. So I'm just going to get rid of this over here. Okay, so now BG over CG is going to be equal to BE, the whole of BE. Oh, come on, pen. So the whole of BE is going to be, well, BF is 7 and FE is 5 over 2. So that means that BE is the sum of those two over FE is 5 over 2. So now we can't leave things like that, Matrix. We've got to simplify it. All right, so you're welcome to do that on your calculator. Or if you want to work with fractions, that's fine. What do you get as a final answer?
I got 9.5.
How much?
9.5.
Okay, I didn't get that.
Ma'am?
I got 19.5.
Yes.
I got 19.5.
I also got 19 over 5.
Over 5, yeah.
Okay, 19 over 5. Okay, so BE was 7 plus 5 over 2, and then we've got to divide that by 5 over 2. Okay, so I got the same thing. I got 19 over 5. Okay. And then they've asked us what BG over CG is, so we would leave our answer just like that. It is 19 over 5. Coco, did you get the same answer?
I did. Well done, guys.
Okay.
Ma'am,
Yes,
Ma'am?
Letabo? Yes.
can we leave it as a fraction?
Yes, you must leave it as a fraction because they've asked you for BG over CG.
Oh.
Okay, so they've asked
Yeah.
you for the relationship between the two. Okay, so BG over CG. So yes, leave it as 19 over 5, like so.
Okay, thank you, ma'am.
All right, absolutely. And unfortunately, we have to leave it there because you guys have got another quiz to go and do tonight. All right, so you go off and go and do that quiz, and then we'll see you all again next week on Tuesday.
Bye, ma'am.
Well done, Matrix. Thanks
Thank
for a
you.
lovely lesson.